Okay, so yesterday, in your homework yesterday, it was all about graphing inequalities, right? With Saxon, you find you learn a little bit of something, and then you move on and you learn a little bit of something else. And then you kind of repeat what you've been learning. So it's sort of called spiral learning, okay? So hopefully that's going to be helpful. Instead of just focusing on inequalities, graphing them, and then getting harder, and then getting harder, and then getting harder, and getting harder, we're doing a little bit at a time. You're mastering that over a period of a few days or weeks, and then you get harder, and then you master that, and then while you're mastering other stuff. Tonight's homework, today's lecture is about tonight's homework, which is ratio problems. So that's lesson 39, okay? 39. Now my guess is most of you have been exposed to ratios.
The next lesson is 38.
Sorry?
I think the next lesson is 38.
Oh, I'm sorry, 38 is what I meant. 38 is ratios, ratio problems. And, but how many people have been exposed to ratios? Raise your hand, I'm just curious. All right, so most, right? All right, so ratios can be written in different ways. Ratios, by the way, I'll just say, are a type of math that is extremely useful in real life. I would be surprised if you guys would went through your entire life without using ratios in some fashion, right? They are extremely, extremely useful. Every time you take, everybody has this dream of building their own house or doing something, like building something or creating something. Whether it's, creating this interior, decorating this house or building this house. If you do, you usually start with like a little plan. You're drawing something on paper. And then you think, oh, I really like the way that looks. That's great. I want to make that. So you want to build something that looks like that. It's ratios that you use to take it from the size of a little teeny piece of paper to a real live object, a gigantic 2-story house, right? And it looks just like the one on your paper, assuming you knew how to do ratios. If you don't know ratios, then your real house will not look like your house on the paper unless you did it by luck, right? The ratios are what allow you to duplicate something small and turn it into something huge, right? So it's really, really useful. So if I said the ratio, like something has a ratio of 4 to 1. There's different ways you could write that. You could write it like this. You could say 4 to 1. That's common. You will see that. A ratio of 4 to 1. Another way you could see it is like this. 4 colon 1. 4 to 1. Okay? The third way, which is the way I think is most useful, at least when I'm trying to take information and use math, is to write it as a fraction. And you write it with the first number in the numerator. So 4 to 1. So that is a that is a ratio. 4 to 1. 4 to 1, 4 to 1, 4 to 1. Those are all exactly the same thing. Okay? Every fraction is what? A division problem. I'm going to add to that today. Every fraction is not only a division problem, is a ratio. You've been dealing with ratios all your life, ever since you learned fractions in 3rd grade. You've been dealing with ratios, fractions, ratios, the same thing. Same thing. So now, let's look at what happens when you put it into a problem, a mathematical problem. A lot of times you'll see something like this. You'll see x over 10 is equal to, I don't know, 20 over 100. I'll keep it simple for now. All right? So this is a ratio. X is to 10. This is how you'd actually say this. X is to 10 as 20 is to 100. X is to 10 as 20 is to 100. That's, I'm going to write that down. X is to 10 as 20 is to 100. This is a ratio, x over 10. This is a ratio, 20 over 100. This is an equal sign, right? What do you have? What is it called when you have a ratio equaling a ratio? Does anybody know?
Oh.
Right? So we're calling this ratio problems, but technically, yes, they're ratio problems, but there's actually a name for this. When you have two ratios equaling each other, they're called proportions. Right. So proportion. Whenever you have two ratios, a proportion. The definition of a proportion. Is two ratios equaling each other. Two ratios equaling each other. And when I told you two ratios each equaling each other. Now when I told you that ratios can be really useful, that's why. Because you can take a ratio and turn it into a proportion. And you can take your little map, your little outline of your house, or your dog house, or your outline of your little jewelry box, or your outline of your whatever it is, and you can turn it into a real thing by using proportions. All right, this is a proportion right here. Because we have a ratio equaling a ratio.
X is equal to 2, right?
Now the, what? I'm sorry again?
Would X be equal to 2? Yeah.
Yes,
Yeah.
it would be, exactly. Now, and how did you figure that out, Liam?
Just division.
Division?
You know,
Okay.
that's a 0.
It made sense. Right, look, I mean, if you took off the zeros, whenever you have a zero in both the top and the bottom, you can just remove them. And that'd be 2/10, 2/10, right? Right. Now, sometimes they're not as easy. This one, I gave you one that's pretty easy to see, right? To see that the answer x is 2, right? Because you can simplify 20 tenths to 21 hundredths to 2 tenths. But a lot of times they're not as simple as that, and you can't quite figure out just in your head what the answer is. So there is a method for solving these. Does anybody remember? Yes, Serena.
Don't you like cross multiply?
Cross multiply. Now that's different than cross reducing and cross simplifying and cross factoring. It's cross multiplying. You're getting them bigger, right? So what that means is I'm going to start wherever the x is. I like to start with my x first. You're going to go like this. That 100 times x is equal to 10 times 20. And I could do it the long way and you'd see, oh yeah, that's all you're really doing. But this is the shortcut. If you just remember this, proportions, solve proportions by cross multiplying. Solve proportions by cross multiplying. Okay, so what we're going to do here, we got x times 100, or 100x, and then I put my equals. That's important. You've got to have your equals. Can't lose your equals. 10 times 200. 10 times 200 is, 10 times 20, excuse me. 10 times 20 is 200. Boom. Okay? Now you have a straightforward problem, right? How would I find x?
Divide both sides by 100.
Divide both sides by 100. Divide both sides by 100. X is equal to 2. And Liam was correct. X is 2. He saw it right away. Sometimes you won't see it right away. And that one, it was fairly easy to see right away. So that is a proportion. Maybe we'll do one more just to see. Let me see if I can grab one from the book. In case there is 4/9. Okay, that's fine. I'm going to erase that. Hope that's okay. Okay, 4/9 should use black. Not use blue. Does that work? No, that doesn't work. I use black. All right, so let's say we have 4/9 is equal to 4/9 is equal to x over 108. All right, I don't know right off the top of my head what the answer is. Do you, Liam?
Yes. Yeah.
I have a pretty good idea, but yes, what do you think it is, Serena?
Well, there's another shortcut that you can use.
Yes.
9 can go into 108.
That's true.
And it goes in 12 times, so
Right.
it's kind of reducing, so
Yeah.
you get a smaller number that you
Yeah.
can work with.
Yeah. So you could say 9 times what is equal to 108, and then multiply 4 times that number,
That's your answer.
and then you get your answer. All right, but I'm going to stick with my little tried and true cross multiply, because as we move into harder problems, these are easy ones. As we move into harder ones, you'll see why. It's going to help a lot to do the cross multiply. So again, I like to start with my x. So 9 times x is 9x. And then I put my equal sign. 4 times 108 is 432. Right? And then I need to know what x is. So I divide both sides by 9, right? And unfortunately, I don't know what that is. X is equal to, so I would have to get out my little calculator or do this. 432 divided by 9. 9 doesn't go into 4, but it goes into 43 4 times, right? 4 times 9 is 36. Subtract that. And then, so that's going to become a 3. That'll be 13. 6 from 13 is 7, right? Right? And then 2. 9 times 8 is 72, right? 48. All right, so x is 48.
That's what I got.
And that's what, like Serena's method, 9 times what would be 108? 9 times 12. Therefore, 4 times 12 is 48. Ah, look at that. It worked.
4800
Right?
equals x 100.
Yeah. So, okay. So now we're going to see how these work in real life problems. Well, I'm not sure how real life they are, but they are real life. I mean, they're the kinds of things you'll see in word problems and stuff. So let's say, I'm going to just copy one that's here. So write this problem in your notes, just so you have it. Where was I? In the same barnyard. Comma. The ratio of chickens to ducks was 9 to 4. The ratio of chickens, I think I just used the same problem before. That's okay. Chickens to ducks was 9 to 4. Was 9 to 4. Yeah, I did use the same one. Ah, funny. And there were
the numbers.
Okay, that's right.
19 to 4.
And there were 117. I lost my place. Chickens. How many ducks were there? In the barnyard, the ratio of chickens to ducks was 9 to 4, and there were 117 chickens.
That's a heck of a lot of chickens.
Okay, so that's a good question.
1/4 chickens
So-
to ducks.
So in real life, it really matters which one comes first and which one is in the top, right? 9 to 4, the ratio, 9 what?
9 chickens to 4 ducks.
So it's important, the order matters here. Look, chickens is first. It says chickens to ducks. That's a ratio. I'm going to write it right now. That's a ratio. Chickens I always put the first one in the numerator, and I put the second one in the denominator. Chickens to ducks. You agree with me? That's that ratio? Chickens to ducks. Our ratio is 4:1. Chickens to ducks.
Obviously,
Right?
it's turkeys.
Chickens to ducks, right?
It's the turkeys.
Then it says that ratio was 9:4. Oh, so that's 9 chickens to 4 ducks. Whatever comes first goes in the numerator. Whatever goes second goes in the denominator. Okay? Now it says there were 117 chickens. How many ducks were there? Okay, so this is the ratio. And they're asking us to turn it into a proportion to figure out whatever. It said there were 117 chickens. This chickens, so I'm going to write this. That's my fraction, 9/4. I'm going to put equals. Is 170 chickens. Is chickens in the numerator or the denominator?
Numerator.
You see why it's helpful to write chickens over ducks? Because you won't make a mistake. Because you see chickens are in the numerator. So it says 117 chickens. I'm going to put 117 over here. Now it says ducks. Ducks is the denominator. It says how many ducks were there? So what do I put here? X. I don't know. So I'll put X. All right, so now I'm going to go like this. Cross multiply. So I've got 9x. 9x is equal to 4 times 117. So that's 400. 4 times 7 is 28, 468. Am I right?
Yep.
Divide by 9. Divide by 9. So x is equal to 468 divided by 9. 5. Look at that. 45 minus this 18. 9 goes in that twice. 52. So there were 52 ducks. Now this is what I have to do. That's my answer, but that doesn't really answer a word problem. Why does it not answer a word problem?
It has to be answered in words.
It has to be in words. So it says, how many ducks were there? So I'm going to say, there were 52 ducks. Make sense?
Why am I writing because
So questions. Does that make sense?
Oh, yeah.
Really important. This was a fairly straightforward one, but it's really important to get in the habit of this. Think of chickens to ducks. Write down chickens over ducks. Then you won't mess up later on. This is where people mess up here. A lot of people would say, oh, well, it's x over 117. No, it isn't. The chickens go in the numerator, so the 117 goes upstairs. The x goes downstairs. The unknown, the ducks, are downstairs. Right? So that's it. That's the lecture on ratios. Really, really useful stuff. Really useful stuff. More than you realize.